Hey everyone, let's dive right into this explainer and look at a really fascinating shift happening in tech right now. The evolution from static AI search to fully autonomous digital problem solving. If you've been working with generative AI lately, you know we're right in the middle of a massive paradigm shift. We're moving away from simple chatbots that just, spit out basic answers toward actual digital colleagues that can act, reason, and work independently. So the core question we're answering today is one you've probably asked yourself. Why does your basic AI so often just completely break down when you ask it to do more than fetch a simple fact? I mean, we've all been there, right? You ask a system to synthesize some deeply complex problem, and instead of getting a brilliant analysis, the AI gets confused, maybe it hallucinates a bit, or it just gives you this super shallow, surface-level summary. Well, today we're going to unpack the exact architecture that actually solves this. To do that, here's our roadmap. We'll quickly look at the limits of basic RAG, explore the big shift to agentic RAG, dig into short and long-term memory, look at tools and dynamic verification, examine multi-agent reflection, and then finally wrap up with real-world knowledge management. Okay, let's kick things off with Section 1, the limits of basic RAG, and exactly where these systems fail. There's just a massive night and day contrast between a passive responder that executes a single lookup and the active problem solver we actually need for real work. Traditional RAG, retrieval augmented generation, is basically a one-and-done deal. You ask a question, the system searches a vector database exactly once, grabs whatever text seems mathematically close, feeds it to the language model, and spits out an answer. And that's the whole shebang. It's completely static. And that introduces a really critical point of failure. I kind of like to think of this as playing the retrieval lottery with your data. Because traditional RAG relies entirely on mathematical vectors, which, let's be honest, are just huge sequences of numbers, to find semantic similarity, it can so easily pull the wrong chunk of data. If your query is ambiguous, or if it requires connecting dots across multiple steps, basic RAG just throws its hands up. Its usefulness basically falls off a cliff when you ask it a complex enterprise question. Which brings us right into Section 2, the shift to Agentic RAG, or active problem solving. So, what is Agentic RAG? It's all about transforming the AI into an active participant. It can identify gaps in its own knowledge, call the right tools, and literally loop its processes until your task is completely resolved. Instead of doing one blind retrieval, the AI model acts as a true agent. It looks at your prompt, takes a breath, and creates an actual plan. If it pulls data and realizes, hey, this is incomplete, it doesn't just give up or guess, it refines its own query and searches again. It's really about giving the AI the autonomy to make its own decisions at every single step of the information lifecycle. We are turning those static, boring lookups into dynamic, multi-step problem solving. The agent acts like a really smart traffic cop, figuring out the best way to chunk data, evaluating what it found, and making absolutely sure the final answer is perfectly grounded in reality. Moving on to Section 3, short and long-term memory. Let's look inside the agent's brain. Think about it. Without memory, an agent would basically wake up with amnesia every time you talk to it. But by using a temporary scratch pad and a persistent library, it can actually learn from experience. Short-term memory is like its working space during a task. It tracks which steps it just finished, what tools it just used, and what the intermediate results were. It's like a buffer for the last 10 to 20 interactions. Once the task is done, boom, that scratch pad is cleared. Long-term memory, on the other hand, sticks around. And what's super cool is how long-term memory is broken down into specific types, letting the system build compounding institutional intelligence over time. You've got episodic memory, so the agent remembers past events and exactly how you like things done. You've got semantic memory, which holds general facts and rules about the world, usually in those vector databases, and procedural memory, which stores learned skills so it can do things automatically. This means the system literally gets smarter and faster the longer you use it, so you don't have to endlessly repeat yourself. All right, Section 4, Tools and Dynamic Verification, how it takes action. This happens through a step-by-step logic sequence known as the REACT loop, which stands for reasoning and acting. This is the absolute engine of Agentic RAG. First, it plans and breaks your query down into smaller subtasks. Second, it selects a dynamic tool for the job. Third, it observes what the tool spits back and reasons about it. If the result is garbage, it realizes the plan failed and it iterates. It loops back, tries a new search or a different tool, and keeps going until it has everything it needs to generate a solid final response.
And these tools extend the agent's capabilities way beyond just its initial training data. You can think of them as the hands and feet of the agent. They let the AI run code interpreters to do some heavy math, scrape web pages for breaking news, or query a live SQL database. It's no longer trapped in a box of its training data. It can actively go out into the digital world and grab exactly what it needs to solve your specific problem.
Which brings us to the climax of the architecture, Section 5, multi-agent reflection and correction, ensuring accuracy. Because with all this freedom and autonomy, we hit a massive roadblock. How do we actually trust the output? This is the ultimate risk for enterprise AI. If you leave an agent to basically grade its own homework, it might generate stuff that sounds super plausible but is completely, totally wrong. Research actually shows that an AI is pretty bad at catching its own mistakes. It can write a beautiful sentence that is factually completely incorrect, and if you ask it, hey, is this right? It will confidently tell you, yep, looks great to me. So to fix this, we have to separate the execution from the evaluation. We use a dual component setup called the reflection pattern. This forces two completely separate agents to debate and fix the work before it ever hits your screen. You have the doer agent, who hustles to research and draft the initial response. Then, that draft gets passed over to a critique agent, and the critique agent's only job in life is to be a harsh editor. It evaluates the output, runs unit tests, fact checks, and if it finds a mistake, it kicks it right back to the doer with notes on how to fix it. I really want to pause on this number for a second. 18.5. Because implementing this exact multi-agent reflection pattern can improve problem-solving accuracy by up to 18.5 percentage points. That is just a staggering leap in reliability. We're not talking about a little minor tweak here. We are talking about the difference between a fun novelty tool and a highly trusted enterprise-grade system. I mean, jumping from a baseline accuracy of around 78% all the way up to 97%, that proves this reflection loop is an absolute game changer. And this isn't just theory. It's been validated across multiple major AI models in academic research. Simply by adding a post-step evaluation where agents debate and verify, the hallucination rate absolutely plummets. Finally, let's ground this in reality with Section 6, real-world knowledge management and uses. Rather than just asking basic trivia like, what was our Q1 revenue? These systems can autonomously handle deeply complex directives. Imagine you're a financial analyst. You can ask the AI to compare Q1 to Q3 revenues, cross-reference that with regulatory filings changes, and generate a full risk assessment based on all of that. In customer support, an agent can dynamically route a multi-layered ticket and immediately invoke the right account tools to fix it. In legal research, they can autonomously cross-check statutes across huge libraries of precedent. And this points exactly to where our future is heading. We aren't just deploying simple chatbots anymore. We are onboarding autonomous digital colleagues that will actively orchestrate tasks across your entire software stack. These synthetic workers are going to maintain persistent identities, they're going to learn the quirks of your specific enterprise, and they'll collaborate seamlessly right alongside human teams. So, as we wrap up this explainer, I'll leave you with this final thought. Agentic RAG isn't just some neat upgrade to a search bar. It is a fundamental shift in how your business gets work done. By combining persistent memory, dynamic tools, and rigorous multi-agent reflection, we're finally unlocking AI that doesn't just answer questions, but actively solves real complex problems. Thanks so much for joining me today, and I highly encourage you to start thinking about where these digital colleagues are going to make the biggest impact in your own day-to-day workflows.